Android operating system for mobile, or Windows operating system for desktops, and Linux operating system also for desktops. And all these, we have different versions. So now in this course, you learn what is the function of an operating system. What are the different types? How do operating systems work? These are the things we learn in this course, right? So in this chapter, it's more or less a revision of what you have learned with Dr. Tahari. It will just try to briefly explain what it means and briefly explain the functions of the operating system, the different types, and how all this works. So in general, operating system actually is a system software that helps the computer to manage computer resources. Okay, and now that's take us to what is computer resources. Computer resources are the different components of the computer, like the CPU, the processor, okay, or we can say the memory, the RAM, okay, or the ROM. All these are computer resources, okay. Or we can say storage device like the hard disk of the operating system of the computer. All these are managed by this software called the operating system. So basically, operating system is a software that makes the hardware to function optimally or correctly. Of course, just having hardware is not enough for the hardware to work. You will need a software to make it work. So that software that makes the hardware to function is called the operating system. So operating system plays an important role in the interaction between the user and the computer. Okay, now this is another thing, because we have two different languages that plays here. Okay, human beings, we understand natural language like English and Arabic, but the computer did not understand this language. The language that the computer understands is low-level language, or zeros and ones, binary. Okay, if an instruction is not in 0 and 1, computer cannot understand it. Okay, so if this is the case, the human beings understand natural language like English and Arabic, while the computer understands zeros and ones, which is binary. So how will the computer and the human beings be able to interact and basically understand each other? Then you need an interpreter. And that is the function also of the what? The operating system. So the operating system is a software in between the hardware component of the computer and the human beings, and it helps us to understand the instructions of the computer, which are normally in zeros and ones, convert them into a natural language that we understand, like English, Arabic, French, German, or any language, okay, so that we can be able to read it. And likewise, if we submit an instruction to the computer in any natural language like English, Arabic, German, French, or any language, the operating system also functions, in this case, as an interpreter, okay, to help us to be able to interact with the hardware device, okay, so that the hardware can now be able to understand the language or the instruction that we pass to it, okay. So the operating system plays this function. There are basically different types of operating systems. The commonest ones that are used on desktop devices are the Windows operating system and, of course, the Linux operating system. So this discussion for today, we will emphasize more on these two operating system types. So in this chapter, we define operating system and its components, and the different types of operating system, and the basic Linux operations. Okay, now for the basic Linux operations, we already taken the lab exercise on Linux. Okay, so this I will skip most of the commands. I will only explain basically the theory part in the slides. So if we come to the lab, we will now have to do the lab exercise. Again, I will use this opportunity also to correct some of the steps that we took the last time that becomes a little bit complicated for us. So I will explain why most of these steps are like this and what are supposed to do. I mean, what are the steps that we're supposed to take in the lab to make it function properly. So let's look at the definition of operating system. By definition, operating system simply means a system software that manages and controls computer hardware and software resources. So not just the hardware resources, also there are software resources like programs that the operating system helps to manage. So let's look at this diagram together. Wa alaikum salam. So we have the computer hardware, okay? The computer hardware consists of the hard disk, okay, the system unit, the monitor, and stuff like this. And in the system unit, we have the processor, we have the memory like the RAM, and of course the hard disk, okay. And of course we have input-output devices such as the mouse, the keyboards, and of course the screen, which is the output device, okay. So how can we be able to interact with the hardware devices and make it work? So basically, the user, me and you, will have to send instruction to software application like Microsoft Word, Excel, or PowerPoint, and this application will have to send this information to the operating system. Okay, the operating system now have to interpret this information into a language that the hardware can understand, because the hardware actually understand only zeros and ones, that's binary. So after converting this binary into machine readable, then the hardware can actually process it. Once the hardware process the instruction that we give, then it have to give us back an output, right? So the operating system receive this output from the hardware, okay, and the hardware instruction, which is in zeros and ones, will be converted to a machine readable and then send it to will be converted to a natural language and then send it to the application like Microsoft Word, Excel, or a PowerPoint, or any other application, okay. And then this instruction can be read by the user, that's by me and you, okay. Then we can see this instruction in Arabic or in English or any other language that human beings can understand. So this is the process by which the operating system can interact with users, or the function of the operating system. So what are the functions of the operating system? Number one is a system call interface. Okay, it helps to call different functions in the operating system and make them to perform these functions, okay. And it also serves as process management. Now that takes us to the question, what is a process? Process are running programs on the computer. All the application programs that you have running on the computer at the same time are called processes. Okay, it's the operating system that manages all these processes, and you will be able to play music. While you are playing music, you are also typing. While you are typing, you are checking the blackboard and browsing the internet. So how many processes I just mentioned? Like 4 or 5. Sometimes you can have almost 20 processes running on the device at the same time. So the reason why they can all work at the same time is because the operating system is managing all these things. Okay, that is called process management. Then we have the memory management. Now, all these processes that we mentioned, they all need the memory to work. So it's the processor, the processor works together with the operating system to assign the memory space to all these programs that we mentioned. So if you need some memory space because you want to browse and play music, the operating system will simply assign and allocate and deallocate these spaces on the memory. So memory management is one of the main functions of the operating system. Then we have file system management. We have different types of files. We have the FAT, we have the NTSF, and we have the EXT files, especially in the Linux operating system. We have many other types of file extensions. Okay, all these type of files need to be created, sometimes deleted, sometimes modified. Okay, all these functions are performed as a result of the operating system. So the operating system helps us to manage file systems. So file system management, okay? And the driver management. Now, drivers simply implies third-party applications that control specific hardware devices. For example, we have a printer here. This printer, we want to connect it to the computer. If we want to connect it to the computer, yes, we can do it, but it cannot work until we have to install a printer driver. Okay, so the printer driver is installed to make the printer work and allow the computer to simply understand that a printer is functioning on it. Now, it is the function of the operating system to accept the driver into its kernel and allow the driver to send instructions to the processor. Okay, so this function is also one of the functions of the operating system. So operating systems accept third-party drivers. For example, not only printer, we have scanners, and sometimes we have external cameras. A camera that you want to connect, like surveillance cameras and stuff like this, you can connect them to your device and it works. But why it works, it's because a driver has to be installed. So once this driver is installed, it means that a driver is an additional instruction into the operating system, and it allows the operating system to recognize this external device that you add to the computer. Okay, so a driver management is actually one of the functions of the operating system. So let's look at the components. There are different components of the operating system. However, operating system can be divided into two different types of spaces. That's what we call the kernel space and the user space. Okay, so we have the kernel space and the user space. So to explain this, we need to know what a kernel is. Who can tell me what is a kernel? Based on your experience in operating system class. A kernel is it's a software program. Yes, it is. But it's more than a software program. It is. Yes, it's a software. But I want to hear something more. A kernel. Have you heard of the word kernel before? This one. This one. Have you heard of the word kernel? Yes, Zainab. Kernel. Have you heard of this word before? A kernel. Kernel. So what is it? Yes, yes, I'm sure you had it before. So far you are in operating system class, you must have come across this one. The kernel is the core of the operating system. Sometimes it's called the heart of the operating system. Okay, it is the first set of codes. That's why I say I agree. It's a program, of course. Okay, it's a program that is the first set of programming codes that get loaded or that can load into the memory of the computer the moment you boot the computer. Because it's so small, the moment you boot the computer, it jumps and loads itself into the memory. And then it will give you the basic functions that you can actually require for you to be able to operate the computer. With a kernel, you can easily go into the settings of the computer, and then you can go into the CMOS, okay, or into the BIOS of the computer, okay. This is because the kernel is being loaded into the memory. Without the kernel, you cannot have this function. Okay? It's as good as saying the computer is off if you don't have the kernel loaded into the memory. So basically, it's the heart of the operating system. Okay? It is at the center of the operating system. It's the core, the most important aspect. If we discuss about Linux operating system, we can say we have two different types of users, or three different types of users in Linux. One of them is the root or the super user, right? The super user have all powers and permissions to play around with basically all aspects of the operating system. The reason is because the root plays from the kernel of the operating system, from the heart of the operating system. So in Linux operating system, it's all about becoming the root. Okay, it's all about becoming. Once you become the root, you have the permission to do everything. Okay, but if you are a simple user or a common user, you don't have permission to other users' accounts and directories or files. Okay, you only have permission to your own files, to your own directories, but you don't have permission for others. Okay, so the reason is because the super user is operating from the kernel. That's why it becomes the root. Okay, so basically in this case, the kernel space, from the kernel space, we have what is called system calls and libraries. But at the application layer level, we have the user space. User space interact with applications. I open Microsoft Word, is application, okay? I open Teams now, it's application. I open Blackboard, it's application. So users interact with what? Applications and shells, okay? So instructions from users goes from application, okay, to functions libraries. Users play around with applications, and instruction goes to the function libraries and then goes to the system call before it goes to the kernel. Now, if it goes into the kernel is the one that interacts with the hardware. Okay, the kernel can actually interact easily with the hardwares. So basically, operating system consists of kernels and various applications. And the kernel is essential software that is used to manage computer hardware. Okay, so it interacts with the hardware. Any question related to this? Now, I still come back to the question again. What is a kernel? Yes. You want to try? Wait. You want to try? It's the heart of the operating system. Tell me one function of a kernel. It's It runs process, yes. Yeah, it's correct. It runs process. That's true. I want to hear another one. It manages resources. Now you are telling me the bigger function, which is actually more or less like saying the functions of the operating system. But I'm not asking for the function of the operating system, but I'm asking the specific function of a kernel, which I just mentioned actually, and still is there on the screen also. But I want you to tell me in your own ways. Yes? Who wants to try? So one of the functions of a kernel is that it manages hardware resources. Okay, it's the interface of the operating system that have direct contact with the hardware. Okay, the hardware receive instructions from the kernel. Okay, so it's a direct interface between the hardware and the applications that users are using. Okay, so like if it is like any application that you use, be it Excel, Microsoft Word, or be it any browser, after you receive this info, you send this information to the applications. The applications basically send it through system calls to the kernel, and then the kernel will be the one that interacts actually with the hardware, like the processor, and then the instruction will be executed. So different types of operating systems. Oh goodness, what did I touch? We have different types of operating system, like the Unix, the Linux, and the Windows. The Unix is instruction-based operating system. Okay, it uses command line, just like what we have in the Linux operating system, CLI. So you have to go to the command line and just start writing the commands. Okay, that's how Unix is. And actually, it's the first that was invented before Linux comes into play. So Linux only borrowed this idea from Unix to develop on this interface. Okay, so basically in Unix we have different types. Solaris is one of them. Okay, we have the HPUX, IBM AXI, AUX is also another Unix operating system. These are some examples. In Linux, of course, we know about the Ubuntu, the Kali, the Red Hat, okay, the Kali, CentOS. Which one did we use? I think we use Ubuntu, right? So all these are different versions of the Linux operating system. But in Huawei, they use what is called OpenOiler. OpenOiler is also a Linux operating system, and it receives the same commands that we use in the lab for Ubuntu, okay, or Kali, Linux. All of them, they use the same commands, okay. So it's just basically the difference is based on how it's being designed, okay. So Linux is free because it's open source, and different companies actually develop on the Linux interface to create their own distros. Okay, distros means another version of it. Okay, so that's why it's more secured than Windows operating system. In the case of Windows, we have different Windows Server 2000, 2003, 2008, 2012, 2016, and 2019 are some of the servers that we have in Windows Server. If you have taken NOS with Dr. Zubair, you must have used probably 2012. Yeah. very good question. Okay, so the Unix is command based. Okay, the Linux is also command based. However, it now has some features that helps with graphics. Okay, it has graphic features. Like if you finish installation, it takes you to the desktop, right? On the desktop, you can actually see some applications that are graphic-based applications. But the main purpose of Linux operating system is not to use the graphics, rather to use the command line. Okay, on the command line, it makes Linux to be faster, okay, and it manages more resources because graphics actually takes time to process in computer. So that's why Windows operating system is designed based on user friendliness to use the mouse and play around. Okay, so Linux uses sorry, yeah, Linux is just like Unix. Okay, it uses command, okay, and is based on permissions. Read, write, and execute permissions are what we use in Linux. However, Windows operating system, they are designed for user friendliness. So they are graphic user interface based, GUI, while these ones are CUI, command CLU interface, CLI, command line interfaces. So after you go into the desktop in Linux, you press the Control-Alt-T, then it takes you to the command line, and then you can start processing the commands. So we will just discuss about the features. As I said, I will skip the commands because we are familiar with them. Mostly you've taken them in operating system class, and also we have some few labs related to the commands. So the features of Linux operating system is multi-platform design. That means that it have multiple hardware platforms that it can work on. Okay, it can work on different types of hardwares actually. It is also multi-user and multitasking, meaning that you can create different users on Linux. Okay, that's multi-user. And multitasking is you can actually run more than one task at a time, okay, on Linux. Actually, the previously designed Linux operating systems, they are single task because you have to run the command and wait for it to execute. But now they are actually multitask and multi-user. You can create many users simultaneously, and you can run multiple programs also simultaneously on Linux. And also, it's free to use. That's to say, it's open source. Now, Linux is open source, but Windows is not. Windows is subscription based, right? You need to pay to use the Windows, except of course you're able to crack it. But again, in addition to this, Windows operating system, you cannot have the source code that designed Windows operating system. It's not available. But in the case of Linux, the source codes that design Linux operating system are available online. You can actually download it. If you have the skills, you can modify it to suit the purpose that you want to basically create. So what it implies here is that in terms of security, Windows operating system is less secure than Linux. Why? Because the design of Windows operating system is a standard design, okay, and it doesn't change. Anytime you see it, it is the same design, the same architecture. So if you see the Windows operating system in System A or in Company A, if you go to another company, it is the same Windows operating system that is there. Okay, it doesn't change. The architecture did not change. So if you know how to penetrate, okay, or how to crack and hack Windows operating system in Company A, If you go to company B and you apply the same method, it will work. Why? Because it's the same design. Okay? But in Linux, it is not the same design. Okay? Company A will have his own design different from company B. Why? Because it's open source and they can change the codes. That's why we say it's more secured. Okay? So when I explain this to one other person, sometimes they ask me, okay, what is the purpose of them making it free? How will they make their money? This is the question that the student asked me. How will they make their money? What is the purpose of taking all this time to design something so important and then you make it free? How will they make their money? Who can answer this question for me?
I think because they already pay for the money for the big company.
Okay.
The company makes it free for the users. If I create something, I buy it for you because you are the big company and everyone know you.
Okay.
I already take my money about my work.
From the big company.
Yeah, but you yeah, you give it for the other thing.
Maybe. What if we don't have any big company to buy it? Because actually, most open source applications, they don't have any big companies. Most of them are even startups. If you go to the Apple Store, you go to what is it called, the other one? Apple Store and Play Store, right? You will see many applications are free, open source, free. And you just download, you don't have to pay anything, and you start using. And the person that designed it are probably a student like you. So why did they take so much time to do this and only to make it free? This is the question, you know. They asked me this question also. So the answer is actually straightforward. Okay? If you see any application that is free, it's not free in the real sense. Yes, it is free for users to use, but they make the user to be their product. Okay? So if you download the application, you didn't know, you don't buy anything. In most cases, we don't actually buy anything. We just download and use. Okay? The PlayStation, sorry, the Play Store, the iOS, they have to pay the users. So no, they don't pay the users. They pay the person that developed it. So her answer may be right, but the payment is based on downloads. That's why any application you go, you will see how many people have downloaded it.
Yeah,
This is what they count to pay the person that is developing this. Now, we as the users, if we visit the Play Store or the Apple Store, we have to go through adverts. Okay? So the Apple Store and the iOS Store, they get their money through these companies that advertise. You will see a lot of adverts related to games and stuff like that. These companies, they pay to iOS Store and also to Play Store. Okay? If they pay them, the more people are visiting to download the application means that they are doing this advert. Okay? So part of the money they collect for the advertisement, they use it to pay the developers based on how many people have visited. Now, this is what happened in a normal application for mobiles. Also, a website is the same. Okay? In websites, some websites you will see at the bottom they write the number of people that visit the website at the time. Okay? So actually they also advertise on this website. So the more you visit the website to download, the more basically you become a viewer. Okay? Now how do like Twitter, they pay people now, right? I don't know if Instagram, did they pay people? I mean, they pay content creators. Twitter, I know they pay because I've been paid before. Twitter, they pay, but I don't know if Instagram, they pay money for the content creators. If you post something, do they pay you? Instagram. I know that Facebook, they pay. Also, Twitter they pay. I don't know if all these like TikTok, I'm not sure, but of course YouTube they pay. All this payment is based on what? Views, right? Views implies the people that visit, right? If you visit, it means you must have passed through the adverts. And they pay the advertising companies they pay to YouTube. And YouTube now take part of the money to pay the people that create the videos. So this is how it works. So also, if we have a free source application like Linux, it will be on a certain website. So the more you visit the website, you become part of the hit, what they call the hit in the case of a website, the viewer. Okay, and if you download, it will count you as a download. So at the end of the day, how many people download will determine how much you will be paid to the company by the advertisers also. Because the advertisers also, you will see the different adverts coming up on the website. So these advertisements basically are the revenue that the company will generate to pay the developers of the application. So that's how it works. So of course, it's free to users. But of course, the developers find their way to get their own money through revenues, advertisements and revenues. Everything in a Linux operating system is considered to be a file. So be it a program, a musical file, a directory, which is also called a folder, they are all considered to be a file in Linux operating system. This is how the directories are designed. We first of all have the root directory. Under the root directory, we have the bin. We have the directory for all user programs, which is called the bin. The dev/dev is for device file directory. And then we have the lib, that's the library, system library directory. For removable media like USB port, we have the media/media. The opt is designed for storing application softwares. Okay, application softwares like the operating system software. Then we have the boot directory for bootloader files, and we have the etc. Actually, the etc is one of the components that we use in Linux. Is configuration file directory. Then we have lib64 for 64-bit systems or 64-bit machines, and we have the mounts for mounting directories. So these are all the directories that are under the root directory in Linux. So let's look at one type of Linux, which is called OpenEuler. OpenEuler is just like the Ubuntu that we use. There's no difference, okay, except that OpenEuler give some additional features, especially related to cloud computing. Okay, it has cloud computing features, it has big data features, database features, and AI. So OpenEuler is actually designed by a company called OpenEuler, but then later on they bought them, but they were bought by Huawei. Huawei is the new owners of the OpenEuler, and is the Linux operating system that Huawei is using for their products. Okay, so for any Huawei device, they use this as one of the operating systems for Linux operating system. So it's called Euler OS. You can see the logo looks like this, OpenEuler. You can visit this website and download it just like the way we download Ubuntu. Let me see. So if you open this website, it will open this way. This is the interface for the OpenEuler website. So you can go down and you can see that it has features related to servers, to clouds, to edge computing and embedded devices. These are the features that OpenELA can actually run on. Aside from that, it has features related to NPU, okay, NPU, GPU, and DPU. Actually, these are advanced CPUs. So how do you use it? You have to download. You go to downloads and you go to OpenELA 24.09. This is the latest version. If you click on that, it will take you to download and you will see it. It's actually 4 gig in size. And of course, you have the SHA 256 hash to be able to check for integrity. Okay, so you can download it from here. Once you download it, you can this is the ISO machine. You can install it just the way we install the Ubuntu on VMware. The same way you can install it and you can use it. It uses the same command with Ubuntu. Okay, so I will stress you to download it and install it because actually we already installed Ubuntu before and it performs the same function. Only that this one, yes, it has additional functions related to the cloud part, okay, and also it has some edge computing device aspect and server aspect, okay, but also Ubuntu has this aspect that deals with networks. That's why we started with networks basics before we go to operating system basics. Okay, so the commands are there at the end of the lab that we used the last time. Okay, maybe the next class we have to take the commands again because I think we took only 1 to 5, right? So we will try to complete the remaining commands in the next class. Yeah, so this is the website just to show you to have an idea of how it looks like. Yes, so the OpenELA is also a multiprocessor. It's a multiprocessor architecture. It has the x86 and ARM features in it. In Linux operating system, we have the Red Hat is one of the distros, the Debian, and the SUSE. Then we have the OpenELA. The OpenELA has a community, basically people that improve on the existing version. So the first version, we have the community version, and the community version, one of the versions is called Kylin version 10, and then iSoft v5.1, and then Ulix OS 1.0. These are all derived from the community. So basically, that's why I said that if you are using Linux machine, it can differ in architecture from one company to another because actually each company is making their own in a different way. Okay, so that's to say from the OpenELA original one, you can see that now another company have designed their own Kylin version 10. Another one designed their own and call it iSoft, and then another one. So all these are community versions that are released. In the OpenELA, it's actually user-friendly. The interface is user-friendly, and it has functions related to disk management software, which is very similar to a middleware, and also underlying software hardware, uh, storage hardware. It can manage storage hardware. It can actually also manage drives and partitions. Okay, of course, this has to do with what we call objects and properties in Linux. Any question? I have a question. What are some of the functions of the new Linux operating system called OpenOILA? One of the functions of this operating system, what are the things it can do for you? Here, okay. Um, it can manage database, big data, and cloud computing. And of course, it has function for AI scenarios. Okay, so the OpenOILA actually can be used for all this. The file system of OpenOILA is similar to what we have in most Linux machines. Okay, in Windows operating system, there are two types of file systems that are used. Okay, we have the FAT and what? And what? In Windows, NTSF. In Windows, these are the two types of file system. Actually, we mentioned them in previous classes. Okay, we mentioned them in previous classes, FAT and NTSF. Also, if you have done forensic class, you definitely have come across this. FAT and NTSF are the two file systems used in Windows. But in Linux, they use the NTSF, okay? But they have other ones aside from NTSF. And instead of FAT is file allocation table. Instead of FAT, they call it v5.0. They call it v5.0. So they have the NTSF and they have v5.0. Instead of FAT, they call it v5.0. But in addition to this, they have other ones, okay? Like EXT. EXT have different versions, 2, 3, 4, and many others, okay? They have the Minix, MS-DOS. All these are different types of files in Linux operating system. So Linux have different file systems. So, but the commonest one is the EXT, XFX, the v5.0, which is the same thing as FAT in the Windows, and the ISO 9600. These are the file systems in Linux operating system. So in OpenOILA also they use the same file systems. Linux is now having both user interface and the CLI. You asked me at the beginning, and I said that yes, even though it's designed on command line, but it has some graphics. Likewise, the same thing with OpenOILA, it has some graphics, but of course, the main strength of it is basically the command line. The graphic elements makes you to be able to use the mouse on it. But the command line, it uses only the keyboards, right? Where you need to enter the commands and then you can be able to run whatever you want to do. Now, the problem with the graphics, it makes the system to be slow, actually, okay? So it's not easy to manage computer resources with the graphics user interface. But with the command line, it's more efficient in managing computer resources, okay? And it's very fast, okay? It executes the programs faster than once it's on GUI system. So the CLI is actually faster more efficient, and more secured. So why do we have to use the CLI when we actually have the graphic interface that is more friendly? So the reason why we use the command line is because it's higher in terms of efficiency, okay? It's faster to run, okay, and it manages more computer resources. That's one point. Second point is that we use the command line because lower overhead compared to GUI, meaning that it doesn't make the system to be slow. If you use the graphic user interface, it actually have to run a lot of graphics, so it uses a lot of system resources. But if you use the command line, no graphics, it simply allocates the space and execute the operations. So it's actually faster and more efficient. And sometimes we do not have any option rather than only the command line. So because actually the Linux operating system is designed based on the command line, therefore the basic ones still use the command line and do not have the graphic user interface. In some cases, it will give you option to install the user interface before you can use it. But in most cases, the command line is the most important interface of a Linux. So it comes with the command line automatically. Yes. So this section just simply discuss about shortcuts related to Linux operating system. The tab is when you want to complete a command. You start a command, you want to complete it, you simply press the tab, it will complete the command for you. If you use double tap, double tap to list all available commands that you have on that interface. Then you have the up and down press, and then you have the home. The home will take the cursor to beginning of the line. Okay. Then the control A will take the cursor to the beginning of the line also. Control E, this one will take it to the end of the line. And then Control L simply clears the screen. Now, I added this, sorry, I added this screenshot because it will help us on what we did in the lab exercise last time. And I observed that most of the lab exercise, we have to use sudo. Okay, we have to use sudo to run the command in most of the commands. Now, the reason is because we did not use the root. If we use the root, we don't have to use sudo all the time. Now, how do we change from a user to the root? Because the root will operate from the kernel. Okay, so you don't have to repeat sudo all the time. You simply write the command and it works. Okay, so how do we change it? Now, if you finish installation of your Ubuntu, it takes you to the desktop, right? From the desktop, you have to press the Control Alt T, and it will open for you the command line, right? The command line will actually start with you as a common user. So this is a common user. Because previous slides we said there is common user. Yeah, so it starts with you as a common user. Now you need to change from a common user to a super user or the root. Okay, so to do this, you simply need to say sudo password root. Then it will ask you to change your password. So you need to put a new password and repeat the new password again. After you do this, it will tell you that the password has been updated successfully. Now, then you need to sudo your way to become a super user. So you can say sudo, and then you call it su. Su means super user. Once you use this command and press enter, you will now simply see that you will now become a root. So at this point, you become a root. If you see the root appears, that means you are now a super user. Now, in all the lab exercises that we did, all those places that we keep repeating sudo, sudo, you don't need to do that again. You just simply write the command and it will go, because now you are the super user. The super user have the permission to be able to execute all those commands without using sudo. Okay, so I think this should be the first thing you will do when you want to start the lab. Once you do this, you become a root, which is the super user, and then you can run all your commands without using sudo. Okay, so I added this. It's not part of the actual slides. So also in OpenOiler, the same thing happened. Okay, you first of all become the root, change the password. After you change the password successfully, then you become a root. Once you become a root, then you can start running your commands. So OpenOiler and the Ubuntu, the same actually. So you can also run the command from Putty or from X shell. I believe are you familiar with the Putty? Putty is actually the application that you use to run and configure routers and switches. We do routing and switching from packet tracer, right? That's only a simulator. If you want to have a real router and a real switch to run these commands on, you need to go to a Putty. Okay, so if you go to Putty, if you don't have it on your device, you install the Putty. So it will open the Putty, and then you connect the router or the switch with a cable, and then you can start writing your commands. The same configurations that you use in Packet Tracer or ENSP or GNS, if you run them from the Putty connected to the router or to the switch, it will work automatically, because that's how it's supposed to be in the real environment. Okay, the packet tracer is only for practice. Okay, so if you want to connect to a router or a switch, you need a Putty software. Then you can connect with a cable, and then you can configure the router or the switch with the same commands that you use in packet tracer. Yeah, so I already showed you how you can change the password. Okay, you can use password. Okay, it will ask you for the new password, and then you can change the password. Of course, you have to use a very strong password. There are different types of users in Linux. The most important one is the super user, which is the root, the one that operates from the root, right? And the root have a user ID called 0. Okay, then we have the system user. The system user basically is programs or processes. Okay, so programs are called super users, and the user ID is actually from 1 to 99. 1 to 99. So this one, the user ID is 0. That's the super user. The system user, that's programs that runs on Linux operating system. They have ID from 1 to 99. Others are called common users. That's me and you. We are common users. Okay, we have user ID from 1,000 to 60,000. That's the user ID. Okay, you can create users, you can create groups. All these will have user ID from 1,000 up to 60,000. So you can also create files, you can delete files, you can create users, you can delete users. Basically, you can use the ID username, super user, you can give it a name, and you can delete also users. Okay, create users and delete users. So to delete a user, you use userdel and then the name. For example, userdel, you can say Shafi, and then you can delete the user called Shafi. So basically, these commands are similar. What we have both in the OpenOiler and the OpenOiler and also in the Ubuntu. Any questions? No question, right? So now, in the case you want to prepare for final exam, of course, this chapter is not included in the midterm, right? So midterm is chapter 1, 2, 3, and 4. Okay? This chapter will not be included in the midterm. However, you will want to read it in the final exam, of course. So for reading in the final exam, you read up to this stage. That will be the end of this chapter. The other slides are all commands. Yeah, you can see where I put stop here for exam. It doesn't show on the one you have on the blackboard, right? Okay. So you can put that mark. For exam purpose, you can read up to this stage, okay? That's the first 30 slides actually.
So what that really is,
First 30 slides, if you want to prepare for exam, yes. So the other slides are just commands. The commands we will take them in the lab. Okay? It's not part of the theory section. So if you have any question related to this, so let me just quickly go to the last section. Yes, let's attempt this question. Which of the following statement is incorrect about file system? Incorrect about file system. Number one, a file system is a method and data structure used by operating system to identify files on storage device or a partition. On storage device or on a partition. True or false? A file system is a method and a data structure used by operating system, by the OS, to identify files on a storage device or a partition. True. B, the software structure that manages and stores file data, is referred to as file system management. True or false? The software structure that manages and stores file data is referred to as a file management system. True. C, the file system manages and controls computer hardware and software resources. True or false? Let's read it again. The file system manages and controls computer hardware and software resources. True or false? Is it true? No, it's not true. It's the operating system that manages computer hardware and software, not the file system. Okay? So this one is not true. If they say the operating system, OS, then we can say it's true. It's one of the functions of operating system to control hardware and software resources. It's the operating system that does that. Okay, not file system. D, the file system organizes and allocates the space on file storage devices, stores files, and protects and retrieves the stored files. True or false? Yeah, this is true. So the answer should be A, B, ABD. Question number 2. Linux is a multi-user operating system that allows multiple users to log in at the same time and allows one user to log in multiple times. True or false? Is it true? How true is this? Linux is a multi-user operating system. Linux. I want to find out from you, is it true or false? Can we have multiple users in Linux? Yes, it's multi-user and multitasking. You remember? Multi-user and multitasking. Okay. And also, now the second part of the question, it says allows one user. Sorry. What is this? Yeah, second part of the question says it allows one user to log in multiple times. Yes, that's true. You can log in. If you are tired, you log out, you come back again and log in and continue working multiple times. You can do that, yes. So the answer is true. Yeah.